Welcome back. So apparently I turned off the video before I finished the problem. Here is the full answer to the last problem in the probability section. Two sisters are buying a car from a lot. There are 100 cars in the lot. There are 20 dark blue cars, 45 light blue cars, 35 black cars. What is the probability that both sisters buy a blue car? So that would be the probability of the first sister buying a blue car. There were 65 blue cars. We combined the dark and the light blue cars. Out of 100 cars in the lot, once the first sister buys a blue car, there's only 99 cars in the lot, 64 of which are blue. Right? And if you're finding the probability of more than one event, you multiply the probabilities. So the probability would be 65 100ths times 64 100ths, and then once you reduce, you get 208 445ths. Right? So that was the last question. Right? And so now let's look at trig ratios and trig graphs, and these questions are specific to help you review for the benchmark. Trying to get unstuck here. My cord's all tangled. All right. There we go. Let a negative 6, 8 be a point on the terminal side of angle theta in standard position. How is the hypotenuse of the triangle determined so that sign can be found? All right. So here is the point negative 6, 8. I already have that up there. Oops. All right. So that would be A, right, which is at negative 6, 8. Right, so here is the terminal side of the angle, right? So that segment from the origin to A is the terminal side of the angle. When we're drawing our reference triangle, we go straight to the x-axis. So the hypotenuse is straight to the origin. Right? The opposite side is straight to the x-axis, and the adjacent side is along the x-axis. Right? So there is our reference triangle. The adjacent side is going to be the x, so that's going to be negative 6. The opposite side is y, so that's going to be 8. And then, so that you could evaluate sine theta, you would simply use Pythagorean theorem to find your missing hypotenuse. Right? And I'm just going to call that r. So r squared equals 6 squared plus 8 squared, which means r squared is 36 plus 64, or 100, which means r is 10. You might have known that without having to calculate it out because this was a Pythagorean triple. Right? But whether you use a Pythagorean triple or whether you solve it out, it's still Pythagorean theorem. And the sine ratio for theta is the opposite side over the hypotenuse. So that's going to be 8 over 10, which reduces to 4/5. Right? That's all there is to that question. Let's look at the next one. All right, given a point x, y, when will cosine be positive? When will cosine be negative? Remember that cosine uses x and x, which is the adjacent side, and then r is the hypotenuse, right? So it's the the line that goes from the origin to our point. Right? So we have some point. When will cosine be positive? So remember, cosine uses x. All right? So here in the first quadrant, this is the first quadrant, both x and y are positive. In the second quadrant, the x is negative and the y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, the x is positive, the y is negative. R is always positive. because it's just a distance, and distance is always positive. Right? So cosine is going to be positive whenever x is positive. Right? So right here we can see that in the first and fourth quadrants, cosine is positive. Right? So cosine is greater than 0 or positive in quadrant 1 and quadrant 4. And cosine is going to be negative whenever x is negative. Right? So that means cosine is going to be negative in quadrants 2 and quadrant 3. So if you just remember the signs of x and y in the quadrant, right, you can figure out when any of the trig functions are positive or negative. Right? So sine uses the y value, and also cosecant, which is the reciprocal of sine, also uses the y value. Cosine and secant use the x value. And all four of them use the radius, which is always positive. The two functions that do not use the radius are tangent and cotangent, and they use x and y. So really could have used the same picture above. I'll just write it again, though. So now we're looking at when is tangent positive, when is tangent negative. All right, so a reminder, x and y are positive in the first quadrant. X is negative, y is positive in the second quadrant. In the third quadrant, I have to write above, I don't have any more space. Both x and y are negative, and in the fourth quadrant, the x is positive and the y is negative. Right? And tangent is the opposite, y, over the adjacent, x. So anytime either of those two are negative, right, our tangent's going to be negative. If they're both negative, two negatives cancel, tangent will be positive. And if they're both positive, tangent will be positive. Right? So let's figure out in which quadrants tangent is positive. Right? So tangent is going to be greater than 0 when x and y are both positive or both negative. Right, so that would be the first quadrant or the third quadrant. Right, so tangent is greater than 0 in quadrant 1 and quadrant 3. Now, if you've got one positive and one negative, right, tangent is going to be negative. Right, so in quadrants 2 and 4, since tangent uses both x and y, if just one of them is negative, then tangent's going to be negative. So tangent is negative or less than 0 in quadrants 2 and quadrant 4, right? Because x and y have different signs in those quadrants. Okay? A lot of the questions on the benchmark are going to be about when are the different functions positive and negative. They won't necessarily ask you about quadrants, but they're going to ask you the signs of the x and y's. Right? But if you just kind of remember our little diagram here, you can remember when x is positive and when x is negative. Right? So in this case, tangent is positive when either x is both positive, x and y are both positive, or x and y are both negative. If they have different signs, in the second quadrant, the x is negative, the y is positive, tangent's negative. In the fourth quadrant, x is positive, y is negative, tangent's negative. Okay? All right, we're going to identify two correct representations of point D. Hopefully you remember this from our work with the unit circle. My triangle could look a little bit better. See if I can fix it a little bit. There we go. All right, so point D is right here. Right, well, if we don't even think of it as a unit circle, we just think of it as a point, right? The horizontal component is A, and the vertical component is B, right? And so A here would be negative, but we're just calling it some quantity A, okay? So our point here would be AB, because A is the horizontal and B is the vertical. You don't have to worry about sign here. I could have put it over in the first quadrant, right? But we're just looking that you can identify the fact that this is the X and this is the Y, right? Now, how else can we identify it? That was one way we could identify it as a point. But remember, this is on the unit circle, right? So on the unit circle, our radius is 1, which means that when we divide, so if you remember from the last couple slides, sine is the opposite, or y, over the hypotenuse, over r. But in this case, r is 1, so it's just going to be equal to the y value. Cosine is x over r, but on the unit circle, r is just 1. So it's just going to be the x value. So another way that we could represent that point is we could represent it as the x is cosine theta. I was saying cosine, so to write an S. So the x is the cosine theta, and the y is the sine theta. Right? So that's two ways that we could represent this point, either as just a point, AB, or we could represent it using our trig functions, remembering that cosine is the x and sine is the y. Okay? That's all there is to this question. Right, here now we're going to look at some graphs, find the amplitude, period, maximum, and minimum values of the graph. All right, so the amplitude is the distance from the low value to the high value. And we take that and divide it in half. Right? So this halfway point would be the midline. The amplitude is the distance from the midline to either the maximum value or the minimum value. So this right here is the amplitude. I'll put amp. So amplitude here equals 2 feet. Okay, and then let's find the maximum min, because that relates to the amplitude. So the maximum is the highest value that keeps repeating. That would be 6 feet. The minimum is the lowest value. That would be 2 feet. And if you notice that if we take 6 minus 2 and we divide that in half, you would get your amplitudes. That's how you can figure out amplitude. You can just identify the distance and divide it in half, or actually take the values, subtract, and divide by 2. So 6 minus 2 would be 4, and 4 divided by 2 is 2, which is the amplitude. And then the period is just where the graph starts over again, right? And you can look anywhere you like. You can start anywhere you want on the graph. I'm going to start here. I'll just start at the beginning, right? And then I look to where it repeats again, right? So we go through the loop, right? And then, actually, you know what? Yeah, I'll just start there. We start here. We go to our maximum value. So I could have done this, by the way, as cosine or sine. I'll do it both ways so you can see. But either way, you'll get the same period. Right? I can think of it as a sine that's shifted or a cosine that's not. Right? So if I start here, sine starts at its low value, right? And then it goes to its exit, it goes to its midline point, and then it goes to its maximum value, and then it goes back to its midline point, and then it goes to its minimum value, and then it starts over again. And actually, I'm starting too far over. Not there, but here. So right here, right, is one cycle of the sine graph. Right? I should not have included that point because it was actually going back to its minimum value. Right? So sine, if I treat this as a sine starts at the midline or at the x-axis if it's not shifted up. Right? So it starts at the beginning, it goes to its high value, comes back, goes to its low value, and then comes back again. Right? So if you can think of one sine wave, right? So this is the intercept, except it's shifted up, and our max, and then the intercept, and then the min, and then the intercept. Oh, there it goes. Ooh, my tape stopped for a minute there. So if you didn't see anything, my board just froze, but it's back. All right, so it started at 1, and then it finished up at 1 p.m. Right? Well, that's 12 hours. Right? So the period equals 12 hours. Right? You may have thought of this as a cosine graph, and if you thought of it as a cosine graph, that would be correct, because sine and cosine are the same. They're just sine is just cosine shifted. Right? If I'm thinking of it as a cosine graph, we would start here at the max, right? And then we go to the intercept and to the min and to the intercept and then back to the max. So this much would be a cosine graph. But notice, either way, same period. Right? So you can actually represent this as a sine graph or a cosine graph. It's just the sine graph would be have a phase shift, and the cosine graph would not. But they're actually the same graph, just shifts of one another. And either way, though, notice that the period is 12 hours. Right? And we've already identified the max and min and period and amplitude, and that was all we were going to identify. Yeah. So this one was a little bit tricky, right? Because you had to kind of hone in on where, the starting point and where it should end. And whether you looked at it as sine or you looked at it as cosine, you would be correct either way in finding the period. All right, we're going to match the graphs with the equations, right? And sometimes we have one period and sometimes we have more. Right? So let's identify there's no shifts on these, just amplitude and period. And so the first one, the amplitude is 1. The period is 2 pi divided by 1/3. That is 6 pi. Right? And since there's no phase shifts here, the starting value for sine is going to be 0, 0. It starts at its min. Right? And so now we're looking for a graph that starts at its min, has an amplitude of 1, and a period of 6 pi. And let's take a look at 23 there. So 1, 2, 3, 4, 5, 6. All right, so this takes 6 pi to go from the start to the end. The amplitude is indeed 1. Right, so this would be the graph, and here's the amplitude. That's an amplitude of 1. Right, and this is our period. That's a period of 6 pi. And so the first one is 23. Let's look at the second one. All right, so the amplitude is 2. The period is 2 pi divided by 2, or pi. All right, so now let's take a look, and I'm looking for an amplitude. Oh, and the start is a sine, so it does start at 0, 0. All right, so now if we look, amplitude of 2, all right, well, this graph has an amplitude of 2, and this graph, I can't circle the number, this graph has an amplitude of 2, and this graph has an amplitude of 2, and so does this one. There's several here that have an amplitude of 2. 3 of them, actually. All right, so now let's, oh, this one does not have an amplitude of 2. Sorry, I did not look carefully at the scale. Not that one. All right, so now we're looking for an amplitude of 2, but we're looking for a period of 1. All right, so now let's look at the ones we have circled. All right, so, and it needs to start at 0, 0. All right, well, if this one starts at 0 on the x-axis, notice it's going to have a shift, and our graph does not have a phase shift. So it is not that graph. So this one's not correct. All right, so now let's look at D. All right, it starts at 0, 0. And then let's see how long it takes to do one cycle. All right, so right here, it's back to the beginning, and it's going to repeat. And that took pi, and that means that D there, that graph there, is some of them are labeled with letters and some of them are labeled with numbers, apparently. So D is f of x equals 2 sine 2x. Right, now let's look at the next one. Amplitude equals 1/2. The period is 2 pi divided by pi. Pi is the coefficient, so its period is 2. And also this is sine, so it does start at 0, 0. All right, so let's look first of all for the amplitude of 1/2. So this one has the amplitude of 1/2, and I don't see any others that have an amplitude of 1/2. Let's see if this graph is right though. All right, starting at 0, 0, that's right. And then let's take a look. It starts, all right, goes through its max, back to the beginning, minimum, and then there it finishes off the cycle. So notice that took 2. So our third graph was indeed graph 24. All right, now we have f of x equals 2 cosine 2x. Amplitude equals 2. The period is 2 pi divided by 2, or pi. All right, and so we had 2 graphs left that had an amplitude of 2. I think there were 2. No, there was 3 graphs, sorry. So we have this one here, we haven't used that one. We have this graph here, and we have this graph here. Right? So let's see which one is correct. And now it needs to have, so cosine starts at its max, right? Because we have no shifts here, so we have to start at our max. That's going to eliminate this graph here, which is starting at 0, 0. Right? And it leaves the other 2. Let's take a look at this one. Right? So our first one here. Amplitude there is 2. Let's see what about the period. So we start here at our max, got the x-intercept, got the min, x-intercept, and back to the beginning. So that has a period of pi. Right? And that would be the correct graph. So graph number A, or letter A, matches that equation. All right, 2 to go. All right, let's take a look at the next one. All right, so we have f of x equals 2 sine 1/2 x. The amplitude is, I guess I decided to write the whole thing. I'll just erase some of it. Amplitude is 2. The period is 2 pi divided by 1/2. That's the same as 2 pi times 2. So that's going to be 4 pi. There was only one graph that had a period of 4 pi left. All right, and so let's take a look over here. Oh, you know, we had one more one more cosine graph, by the way, but it had the wrong amplitude, so on that last question, so it's a good thing I didn't circle that one by mistake. So we're looking for sine. Sine starts at 0 at the beginning, right? So this one is a sine graph. Does have an amplitude of 2, right? This would be 2. And starts the intercept, maximum, intercept, minimum, back to the intercept. That's the end of the cycle, and that took 4 pi. So that B is the correct answer. And looks like I have one more graph, 1, 2, 3, 4, 5, 6. Oh, I have one more graph than I have equations, so somebody won't get used. All right, so our last one, the 4 cosine 2x has an amplitude of 4, and the period is 2 pi divided by 2, so that's pi. All right, so cosine starts at its max. We got 2 graphs it could be. These are both cosine, the 25 and the e. All right, but we need to have an amplitude of 4. This one only has an amplitude of 2. This one, because each one of these lines is 2, has an amplitude of 4. We start at the max. We go through the intercept, the min, the intercept, and back to the max again, and that took pi, right? So that's a period of pi, and so that must be our graph, 25. Okay. I think I've got one more question, and that's it for this one. Which is the graph of 2 sine x minus 1 with the correct amplitude, period, and midline? All right, so the graph we're looking for has amplitude of 2. It's the coefficient in front. No change to the period. So the period is 2 pi. Right, because b is 1. B is the coefficient on x. No phase shift, just a vertical shift. So the vertical shift is the same as the midline, and that's what we add to the sine function. So that's going to be y equals -1. We're shifted down 1. I think the most obvious thing to find is the midline. Right? So let's take a look at our graphs. Right? We want one that has a graph, has a midline of y equals -1. Well, 2 of them do, right? This graph here and this graph here, right, have the midline at y equals -1. The other 2 have the wrong midline, so we can ignore them. All right, so now we're looking for one that has the correct amplitude. All right, so we need an amplitude of 2. All right, let's take a look at both graphs. All right, so from the high to the low. All right, so there's our low, there's our high, right, and that is a distance of 2, right? But remember, amplitude is halfway, right? So it's halfway between the lowest and highest values. Or you could think of it as the distance from the midline to the upper or lower values. So right there is our amplitude. Right here is the difference between the max and the min, but halfway would be our amplitude. So this has an amplitude of 1. And that's not correct. So let's get rid of that one. Let's look at the next one. All right, so here we have our midline, and let's go between our, let's just go from the midline to the upper value. All right, so this would be the amplitude from the midline to the maximum, or the midline to the minimum. And that's a difference of 2, so that's an amplitude of 2. And this is the only graph we have left, so we better hope the period is right. All right, this has a period of 2 pi. If we start here at 0, 0, we go maximum, intercept on the midline, so it's not an x-intercept, let's call it a midline intercept. So midline intercept, maximum, midline intercept, minimum, and back to the midline again. That is a correct period. That's a period of 2 pi. So everything about this graph is correct, and this is the graph that we want. And that is the end of my video. Thanks for watching. Bye for now.